Welcome to qnawire.
Okay, so this is the free body diagram for the machine base. Okay, so there are 4 speed with the angle theta, and there should be a gravity, and there should be a normal force at point A and point B. And since there's a normal force, that means there should be a friction as well, which is Fa and Fb. And the blue arrow here is the xy component of the force P. So we know since the object is in equilibrium, so therefore the net force along the xy direction should be equal to 0. So we have Fx is equal to Fa plus Fb minus P cosine theta equal to 0. So therefore we have P cosine theta is equal to Fa plus Fb. And then we have Fy is equal to Na plus Nb minus W plus P sine theta equal to 0. So therefore we have W plus P sine theta is equal to Na plus Nb. And we know friction Fa is equal to mu s Na, and friction Fb is equal to mu s Nb. So therefore, we have P cosine theta is equal to Fa plus Fb, which is equal to mu s Na plus Nb. So therefore, we have P cosine theta over Wp sine theta is equal to mu s Na plus Nb over Na plus Nb. So Na plus Nb cancel out, so we have this just simply equal to mu s, which is the coefficient of static friction. So therefore, we have P cosine theta is equal to mu s W plus P sine theta. So if we take square on each side, we have P squared cosine squared theta is equal to mu s squared times P plus W plus P sine theta to the power of 2. And this will give us P squared cosine squared theta equal to mu s squared times W squared plus 2W P sine theta, and then plus P squared sine squared theta. And then we know that cosine squared theta is equal to 1 minus sine squared theta. Okay, let me use the red pencils. Oop. So therefore, we'll have such equations here. And then if we do some arrangements, eventually we'll have such equation here. And then we know mu s is equal to 0.30, and P is 500 Newton. W is the gravity of the machine base, which is equal to 75 kilogram times 9.8 meter per second squared. And this will give us the gravity is equal to 735 Newton. So therefore, if we plug in the values back into the equation and forget about the units, we'll have 272,500 sine squared theta plus 66,150 sine theta minus 201,379.75 is equal to 0. Okay. The reason I say forget about units because if you plug in units with the equation, it will be really long. Okay. So just don't forget to put the units for the answer. Okay. So let's keep working on it. So we can apply the formula here. So we have such equation here for sine theta, and eventually you have 2 solutions for sine theta. One is 0.75, another one is negative 0.99. So if we use the inverse sine function to determine 2 angles, we have such 2 angles here. One is 48.6 degree, and another one is negative 81.9 degree. So we know if you take a look at the graph, the angle theta is above the x-axis, so therefore the angle should be positive. Okay, so therefore the negative angle here should be neglected. Okay, so we don't need to use the negative angle here. So the only solution for the angle here should be 48.6 degree. So now let's take a look at the total moment about point B, which is summation MB is equal to P sine theta times 0.4 meter minus P cosine theta times 0.5 meter, and then minus W times 0.2 meter. So if we consider the moments that's in the counterclockwise direction is positive, that means the clockwise moment is negative. Okay, so that's why P sine theta times 0.4 meter is positive and the rest of it is negative. And we know P is equal to 500 Newton, W is equal to 735 Newton. So if we plug in back to the equation and forget about units, we'll have 200 sine theta minus 250 cosine theta minus 147 is equal to 0. And then eventually we can put a square on each side. Okay, so we have 200 sine square, 200 sine theta to the power 2 is equal to 250 cosine theta plus 147 to the power 2. And then we can expand it. We'll have such equation here. And we know that sine squared theta is equal to 1 minus cosine squared theta. Okay, so eventually you will have such equation here. So now let's apply the formula. So we have cosine theta is equal to negative 73,500 plus minus square root 73,500 to the power 2 minus 4 times 102,500 times negative 18,391 over 2 times 102,500. And then we should have two solutions as well. So the first solution here is 0.196. And the second solution is negative 0.913. So if we use the inverse cosine function, we'll have theta 1 is equal to inverse cosine 0.196, which is equal to 78.7 degree. And theta 2 is equal to inverse cosine negative 0.913, and this will give us the angle is equal to 155.9 degree. So if you take a look at the graph in the question, you can tell that the angle theta is now greater than 90 degree. So therefore, the only solution in this question, in this case, is theta equal to theta 1, which is equal to 78.7 degree. Okay, so these solutions can be neglected. So therefore, the range of the angle should be from 48.6 degree less than equal to theta, and then less than equal to 78.7 degree. And don't forget about units. And these are the answers for this question.